So we're going to have a look today at calculating or working out relative molecular mass. Before we do that, we need to think about what the term relative molecular mass comes from and how it's related to relative atomic mass. So if we have a look at relative atomic mass, this is something we've come across before. We will find that if we look at the periodic table, and for example here I've drawn what you will see on your periodic table with the element fluorine, which is in group 7, that it has a relative atomic mass of 19. So this number here, the big number, is the relative atomic mass. It's the relative mass of one atom of fluorine. The actual mass of one atom of fluorine is very, very, very small. It's actually about 3 times 10 to the minus 23 of a gram, but we say its relative mass compared to other atoms or compared to carbon actually is 19. We give the word relative atomic mass a symbol, and that symbol is A with a small subscript r. So if this was the line I was writing on, that r would be small and it would be halfway between the line above and the line below. So that's relative atomic mass. We find it from on the periodic table. We then need to have a look at what relative molecular mass is. Now, it's essentially the mass or relative mass of a single molecule of something, but we've got to be careful there because we can also use relative molecular mass to describe things that are not molecular as well. So it is the sum of the relative atomic masses, the ARs, of all the atoms in a formula. Much easier if we just have a look at some specific examples. Okay, so let's do our first example. Our first example is going to be the MR, the relative molecular mass of carbon dioxide. This symbol here is the symbol for relative molecular mass. If we just go back momentarily and think about why that is, M for molecular and the R for relative. So MR of carbon dioxide. So if we have a look at our periodic table, the first thing we'll see is that the element carbon has a relative atomic mass of 12 and the element oxygen has a relative atomic mass of 16. I've included their relative atomic numbers there just for completeness, but we don't actually need these in this calculation. This is the number we need for carbon and this is the number we need for oxygen. So let's have a look at the formula of carbon dioxide. Carbon dioxide has one carbon atom in it and 2 oxygen atoms per molecule. Carbon, there isn't a number after it, so there's just one of them. Oxygen, there's a 2 after it, so there's 2 of them. So we've got one carbon. One carbon atom has a mass of 12. We've got 2 oxygen atoms. Each oxygen atom has a mass of 16. So 1 times 12 is 12. 2 times 16 is 32. If we add all of those together, then we end up with 44. Another way of thinking about that is actually to draw a diagram of the molecule. So there's a carbon atom with an oxygen atom either side of it. If I add in the relative atomic masses, then we can see that 16 and 12 and 16 gives us a mass for this molecule of 44. Let's have a look at another example. So our second example is going to be beryllium sulfate. Again, I'm just going to write out the masses and the mass and atomic number, the relative atomic mass and the atomic number for our elements. Beryllium, sulfur has a mass of 32, and oxygen, which we found earlier, has a mass of 16. Remember, these numbers I'm not interested in today. I've just put them there because this is how they appear on your periodic table. So let's list the atoms and the number present in our molecule. Sorry, in our formula. Beryllium, sulfur, and oxygen. Those are the 3 elements that make up beryllium sulfate. 1 times beryllium, there's no number after it. 1 times sulfur, there's no number after it, so it's a 1. But then we get to oxygen and there's a 4 after it. So there are 4 oxygens. Let's replace the element symbol with their atomic mass. 9 for beryllium there, 32 for sulfur, and 16 for oxygen. 1 times 9 is 9, 1 times 32 is 32, 4 times 16 is 64. If we add all of those up, we get 105. Let's have a look at one more example, this time including brackets. So we're going to have a look at calculating the relative molecular mass for magnesium nitrate. Let's do what we've done before, which is find the elements on the periodic table because we're interested in their relative atomic masses. 24 for magnesium, 14 for nitrogen, and 16 for oxygen. So you would have to find these on the periodic table if you were going to do this. Let's list the number of atoms present. 1 magnesium. Now, this is where we get a slight problem here because we've got brackets. So the elements inside the bracket is 1 nitrogen and 3 oxygens. But there's a 2 outside the bracket, and that means everything inside the bracket has been multiplied by that number 2. So there's 1 nitrogen inside the bracket times 2 means there's 2 nitrogens. There's 3 oxygens inside the bracket times 2 means there's 6 oxygens. Let's replace the elements with their masses. So 24, 14 and 16, 24, 14, 16, and then do the calculation here. And then if we add all of these up, we get to 148. So just as a summary of the 2 new terms that we've seen, AR is relative atomic mass, and as a hint, you need to find it on the periodic table. And then MR is relative molecular mass. But we do have to be careful in the fact that MRs can also be calculated for substances that are not molecular. Thank you very much.